All right, so we're talking about trigonometric functions on the unit circle. Let's go. On page 71, you should get this goal down. You're going to be able to find values of trig functions for any angle. Okay? This section, or this lesson, just like the other lessons, do have a few things in it. Probably the smallest amount from all the other two sections. So we're doing the first little bit today, and we'll do the last little bit on Monday. Okay? So we're talking about trigonometric functions on the unit circle. And you're going to be able to find the values of trig functions for any angle. Now, before we get started, I need to make sure, especially after looking over your 5-1 prep work, that everybody understands opposite, adjacent, and hypotenuse. So, okay, I'm going to label this triangle sides 1, 2, and 3. I'm going to put theta somewhere in this picture, and if, I want to ask you, what's the opposite sides of theta? You're going to hold up one arm, you can think it's side 1. You're going to hold up 2 arms, you can think it's side 2. And then you're going to stand up if you think it's 3. Okay? Because there is a serious now, well, I won't say it's a serious, but I can definitely tell that some of you guys, like half of your homework, you knew exactly what was the opposite adjacent hypotenuse side, but then the other half didn't. And so I need to make sure when you turn this triangle, you know which is which. Okay? So we're going to practice. It's not going to be on video. When you're trying to find trig ratios of ordered pairs, okay? 5 simple steps. I decided to write them out in steps because, hey, maybe people are meticulous that way. You want to graph the ordered pair, okay? Which means that when you graph it, you need to know, where x and y positive, where x and y negative, etc., etc. Then you drop a perpendicular to the x-axis. Yes, if the ordered pair is in the 3rd quadrant, you're dropping it up. Okay, I understand that concept. But it's basically going to the x-axis, hence why x-axis is capital letters. Then you label your triangle with the information. Use Pythagorean theorem to find your hypotenuse, and then find your ratios, i.e. sine, cosine, tangent, secant, cosecant, and cotangent. All right, now what you see at the bottom are the 6 trig ratios, okay? And they're with respect to a point that's in a coordinate plane, all right? So, clearly, when you're given a point, you're given an x and y value, right? Okay? The x represents the distance from the origin along the x-axis. The y represents the distance from that point running parallel with the y-axis, okay? So basically what you end up doing is you're creating a triangle, all right? Now because you're dropping your perpendicular to the x-axis, the angle that you're creating, your theta is located right here, okay? It's always with the x-axis, never the y-axis, okay? And it's also never with that perpendicular that you drop. Is everybody understanding that? When it's in a coordinate plane, theta is always with the x-axis, the angle that's closest to the x-axis. All right? And so really and truly, if you're able to locate where theta is, then if you remember that sine is opposite over hypotenuse, you won't have to remember that is y over r. And if you remember that cosine is adjacent of hypotenuse, you won't have to remember that it's x over r. Those are basically just another way to represent what we already know in our 6 trig functions. Is everybody following me as I'm saying this? I mean, you're going to end up drawing a picture anyway, more than likely to try to help you out. So, I mean, as long as you label theta in the correct spot, you really don't have to remember these. However, they are there for the ones such as your quadrantal angles. We talked about quadrantal angles. Does anybody remember the definition of a quadrantal angle? It's called a quadrantal angle for a reason. It's an angle that's located where? A little more more specific. Yeah. Not like that. Because technically this is located in the third quadrant, but it's not quadrantal angle. No, not on the fourth. Yes, if the terminal side lies on one of the axes, this is where this is actually going to be very helpful. Okay, because if you have an angle that lies on the axes, you really can't create a triangle with a vertical line or horizontal line. Okay? So then this is where this comes in handy. What's R? Well, R is nothing but the square root of x squared plus y squared, aka that Pythagorean theorem. Alright? So if you're given a quadrantal angle, then these would definitely be helpful because you can't really draw a triangle with it being, vertical or horizontal. However, any other point is fair game to draw a triangle with. Okay? So this is what we're going to do. Here is the foldable activity cutout thing that we're doing today. So you have these booklets, okay? And what we're going to do is we are going to use these booklets, nice little coordinate planes we are going to make, okay? So the one on the front, I don't care which one you make your front, it really doesn't matter. The front, leave for your title page, okay? Leave for your title page. You can design it, draw on it, all you want to. Open it up, though, okay?
Which way are we opening?
Like a book. Open it like a book. Like a high school book, not like a grade book. Okay, this way. So, what you're going to do now, if you have a highlighter, a marker, or something that makes a thicker, darker line, you might want to also pull that out. Because what we're going to do is we're going to create a coordinate plane using this crease of our booklet as the y-axis. Okay? And then we're going to use the ruler to draw a horizontal x-axis. Okay? Should be. So what we're going to do is, these are our examples that are going to go in this little booklet here. We are going to find these 6 trig ratios for this ordered pair. So we're going to have to actually graph this. Now, one thing I didn't count was actually whether or not negative 9 12 actually fit. From your origin, count. Is negative 12 on your thing? Or positive 12? If you can't make it up to positive 12, let me know. I'll change it. It doesn't matter.
No, there's 10.
10? 10? 10?
I got like 9.5.
Okay, so this is what we're going to do. We're going to change this. We're going to make this a 9. We're going to go negative 9, 9. Okay? So in the very first order pair, we're going to plot negative 9, 9. Okay? Everybody gets a negative 9, right? 9 fifths? Negative 9? Okay. So we got negative 9. You got the point? That was step 1, right? Plot the point. Now it says drop down a perpendicular. You're going to drop it down to your x-axis. Okay, it always goes to your x-axis. Basically what we're doing is we're creating our right triangle. The hypotenuse connects from that point to the origin. Always does.
Straight line.
That is a really straight line.
All right? Use your ruler. You got one there. Make yours nice and straight lines too. Make your right triangle. Okay? Now we know our 90-degree angle is here with the perpendicular. And where is theta? Is theta at the top or theta at the bottom?
By the x-axis to the bottom.
By the x-axis, so at the bottom. There is our theta. Question?
So it's always going to be the closest point to 0. That's by the x-axis.
Yeah, you can think of that as the closest angle to 0. The closest angle to the horizontal. You think that? And now let's label our sides. Well, we already know that this side of our triangle is not 9, but it's actually negative 9 because we are in the second quadrant. The signs really matter here, so be careful. If you're in the second quadrant, x is negative, but y is positive. And it should also match up to your ordered pair. So that was step 2. We labeled our triangle. That was step 3. Now step 4 says use Pythagorean theorem to find the hypotenuse. Use one of the other quadrants to do all your work for the hypotenuse. Okay. Use first, fourth, or third. Find the hypotenuse. Use Pythagorean theorem. Negative 9 squared plus 9 squared equals c squared. Negative 9 squared is 81 plus
81.
not squared, but take the square root. Now, the square root of 162, that's not a perfect square, and we can't really give a decimal here because we're looking for the trig ratios. That's what we're doing here, which means we need a simplified radical. This one is going to be 9 square root 2. How did you get that so fast?
My calculator.
The tree method. You said your calculator. Yeah, your calculator does those type of things. But also, think about it. What two numbers did you just add together to get 162? 81. So when you say 81 times 2, exactly. Exactly. You got a couple of 9s. Take out the 9. If you don't like it that way, you can do the square root of 81 times the square root of 2. That turns into 9 root 2. Either way. All right, label your sides. Negative 9 is your adjacent. Positive 9 is your opposite. And 9 square root 2 is your hypotenuse. We are now at step 5. We're going to find the 6 trig ratios. Sine of theta equals what over what? Y over r, opposite over hypotenuse, so that's 9 over 9 square root of 2. That can simplify. To what? And that can simplify to? Can you have a radical in the denominator? So you have to multiply the top and the bottom by that denominator. Let's do cosine. Adjacent over hypotenuse, negative 9 over 9 square root of 2. It's going to be the same thing as sine, but this time it's going to be negative. Again, the signs matter, guys. Tangent is what over what? Opposite over hypotenuse. What's 9 divided by negative 9? Negative 1.
On our test, are we gonna have to remember what sign?
That's why I remember I gave you on lesson 5.1 it was SOHCAHTOA. If you can remember SOHCAHTOA, that you got the first 3. Now the last 3 are they're the flips of these. Sine goes with CSC. So secant. So we have to flip sine. Don't take the simplified form. It's going to do a little bit more work. Take one of the originals. Square root of 2 over 1, which is just square root of 2. Cosine goes with, at our SEC, what was that? What does that stand for? Say what? Secant. And we just have to flip secant, or flip cosine, which is just negative square root of 2. And then lastly, tangent went with cotangent. And that will be still negative 1. Okay? And there you go. There are your 6 trigs. All right? Off to the side in your actual notebooks, okay? Because you know you're going to be gluing in this booklet, okay? So kind of decide where you're going to glue the booklet in. And then off to the side in the note part, I want you to write this down. Actually, I'll do a new page. students take calculus. This is a good way to remember what I'm about to say. This stands for something, okay? This basically stands for when your trig functions will be positive, which trig function will be positive in which quadrants. First off, all is in quadrant 1. Students is quadrant, take is quadrant 3, and calculus is quadrant 4. Again, you're adding this off to the side in the notes section. All is exactly what you think. All the 3 basic trig functions, sine, cosine, and tangent, excuse me, all of them are positive. Every last one of them are positive. However, in the second quadrant, students correspond to which trig function? Sine. Only sine is positive in the second quadrant. Cosine is going to be negative, as we just saw. And if tangent is sine over cosine, y over x, a positive divided by a negative is always going to be a what? A negative. So tangent is negative in that too. Which means that, what's the reciprocal with sine? Was it CSC or ESC? So that means its reciprocal is also positive in that quadrant. Take stands for what? Tangent. So only tangent is positive in third quadrant. As you know, the x and the y are both negative, but 2 negatives divided by each other is a positive. And what's the reciprocal of tangent? So tangent is also positive. Last one, calculus stands for? So cosine is positive and its reciprocal, which is secant. That will help you when you're doing the ones in the order pair so you don't forget which one should be negative and which should be positive. Okay? Flip the page. I want you to do the next one on your own. Baby triangle. What was your hypotenuse? It was the square root of 5. Theta was located right there in the top corner with the x-axis. So your sine of theta was what? Anna, what did you get for the sine of theta? Wait, you said negative 1 what? Like right beside it or underneath it? Close. It's like you half rationalized. So you take the middle all the way. It should be over 5. Because it would have been negative 1 over the square root of 5. So then you rationalize. Down there, you're still there. You don't have to write the 1. Cosine theta was what? Malaysia, what'd you get? Exactly, because you would have had to rationalize that as well. I think before, so like this was what sine was before. Cosine before was a negative 2 over square root of 5, so then you had to rationalize that. Okay? Tangent of theta is what, Isan? It is a 1 over 2. Remember, you're in the third quadrant, so tangent is positive in the third quadrant. As you see, negative 1 divided by negative 2 is a positive 1/2. Let's keep it going. Cosecant theta. Kaylee, what you get? Negative root 5. And the secant of theta. Kayla, what you get?
I got negative 2 square root of 5. For the cosecant?
No, for the secant.
Oh. That's what I got. Is that wrong, probably?
You said negative what?
Negative 2 square root of 5.
Not quite. Remember, you got to flip cosine. So this was cosine originally over here.
Mm-hmm.
So flip that.
Oh, that'd just be square root of 5 over 2. Or negative.
Mm-hmm. Now realize if the top is negative or if the bottom is negative, it makes the entire fraction negative. So you can say a negative square root of 5 over 2. Doesn't matter that it went to the 2 or anything. And the last one, cotangent theta. Monica, what you get? It's a positive 2. Questions? Last one before we move forward. And here's this one. Any questions on this? Watch your negatives, guys. Watch your negatives. Okay? Now, flipping over to the next one. Okay? Sometimes you might be presented with a problem like this. Do I expect you to write all this down? No, but I do expect you to at least get this part in there. This is what's important. Okay? We're still finding, excuse me. We're finding the remaining 5 trig functions of theta because we already know that tangent is 5 over 12. Okay? We already know that tangent is 5 over 12. And we're also told that sine of theta is less than 0. If sine of theta is less than 0, that means that sine of theta is negative. So when you think of your coordinate plane, where is sine negative? Is in number 3 and 4. But out of these two, where is tangent a positive? 3. So your triangle is going in the 3rd quadrant here. Okay? Our triangle's going in the 3rd quadrant. Everybody catch that?
Yes.
Yes.
All right. So I'm going to clear this so I can do my triangle. All right? So I'm looking at the 3rd quadrant. Not the best, but hey, you get my point. Now, at this point in time, kind of doesn't really matter how far over, how far down you go. All we know is that right now, well, we kind of use this. We know tangent is what over what?
12.
Opposite over adjacent.
Opposite over adjacent. Also, yes, 5 over 12.
X over Y.
Close.
Y over X.
Y over X.
Over X.
So we actually know how far over along from the origin we're going to go and how far down we're going to go. So we're going to go over 12 units, and we're going to go down 5 units to create our triangle. Okay? But if tangent is, if we're in the 3rd quadrant, technically y and x were both what?
Negative.
They were both negative. That's how tangent was able to become a positive. This is where, again, watch your signs. Okay? Here's your perpendicular. Theta, top or bottom? Top. Bless you. All right. So we already know tangent. So we need to find sine, cosine, cosecant, secant, and cotangent. I want you guys to find those. All right. What was our hypotenuse? Anybody?
13.
13. So Donnie, what was sine? Negative 5 over 13. And Brian, what's cosine?
Oh boy.
Well, hold on. All right. Well, Angie gave that one to you, but you got cosecant now. Okay. No one tell it. Just Brian. Cosecant theta. Hush now. Cosecant. Negative 13 over 5. E was 13.
He was just
Terrible. Just terrible. Let's see, Alexis, what's secant theta? Negative 13 over 12. And the last one, let's go with, how about top on Angie, what's the last one? Cosecant theta. 12 over 5. Still easy, right? Just make sure that you're in the right quadrant. You guys get down secant theta equals the square root of 3, where tangent theta is less than 0. Get that at the very last one. And let's talk about quadrants real quick. We're not going to do this one all the way out because I'm running out of time, but tangent less than 0 means tangent is, where is tangent negative? Second and fourth. Now it says secant theta equals a positive square root of 3. Secant is the reciprocal of which one?
Sine.
Cosine.
Cosine. So out of these two, where's cosine positive?
4.
So that's where you're going to draw your triangle. And more specifically, we know that secant theta is the reciprocal of cosine. What's cosine normally? What over what?
Adjacent over hypotenuse.
Cosine is adjacent over hypotenuse. So secant is going to be, so when you label your triangle, that root 3 is going to be your hypotenuse. And what do you think is going to be your adjacent side? 1.
How would you write that?
Huh?
How would you write that?
You would draw your triangle in the fourth quadrant and then label your hypotenuse root 3 and your adjacent side 1. You don't have to worry necessarily on how many spaces over is that. It was just more for the visual effect of the first 3. All right? Skip over to page 72. Get this down about reference angles. Reference angles. Everything pretty much has been about, dropping a perpendicular down to the x-axis. Theta is the angle closest to the x-axis. Well, reference angles are basically acute angles. They're always acute angles formed by the terminal side of an angle in standard position and the x-axis. Okay? One thing you want to, of course, make sure is that theta is in between 0 and 360 or 0 and 2 pi, depending on if you're working with degrees or radians. And depending on which quadrant you're in, these things down here at the bottom are pretty much kind of like formulas that you can use. If you kind of already recognize that, hey, it looks like your reference angle is basically the distance away from the x-axis, well, that's exactly what it is. So you don't really need to use the formulas unless you absolutely have to. But if your angle that's given to you is in quadrant 1 and they ask you to find a reference angle, well then, whatever that angle is, that's exactly what the reference angle is. You indicate a reference angle by doing the theta symbol and then an apostrophe mark. It's not called theta tick, but it's actually called theta prime. So theta prime indicates a reference angle. In the first quadrant is exactly what that angle is. However, in the second quadrant, you subtract 180 from, or you do 180 minus the angle that's given to you to get your reference angle. Or if you're in radians, it's pi minus theta. In the third quadrant, as you can see, again, the distance away from the x-axis, or you could do your angle minus 180, or your angle minus pi. And then, of course, if you're in the fourth quadrant, you can determine, hey, well, that's x number of degrees away from the x-axis, or you can do 360 minus theta, 2 pi minus theta. But no matter what, reference angles are always acute, hence always being in capital letters. Reference angles are always acute. We're going to look at a few angles, and we are going to determine their reference angles. All right, so here's the first one. We're going to sketch 3 pi over 4. Then find its reference angle. Okay? Reference angles, again, they are acute. So, 3 pi over 4. Clearly, this is 0. 90 degrees would be here. 180 would be here. 270 would be here. But we're in radians. So, 90 degrees, 180 degrees really can't help us unless we know what their radian measures are. 180 degrees is what as radian? Pi. What about 90 degrees?
Half pi.
Half of pi, pi over 2. Okay? Now 3 pi over 4. Is that in my first quadrant, second quadrant, third quadrant, fourth quadrant?
Third.
It's less than a whole
First.
pi, so
It's in the fourth.
Who's in the first?
It's in the
Second. Because it's definitely more than half, but less than a whole. So remember, to draw your angles, you always start at the positive x-axis going counterclockwise when it's positive. There's your angle, 3 pi over 4, because it said to sketch. Now to find its reference angle is its distance from the x-axis. Well, since we're in the second quadrant, we're going to do pi minus our angle. Just using the formulas on the other page. How do I do pi minus 3 pi over 4? Which is 4. So pi can be written as what over 4?
4.
What's 4 pi over 4 minus 3 pi over 4?
pi over 1.
And there's your reference angle. Pi over 4. Is the distance it is away from the x-axis.
So you would always write it with the pi.
Apostrophe. It's an apostrophe. Where's the negative 150?
The second one.
Positive 150 is in the second one, but if I'm going negative,
Third.
it's going to be in the third quadrant. Negative 150.
How many times do you have this page? 2? I mean 3 or 4?
There's going to be 3, but I doubt I'll be able to get to the last one.
Okay.
I have one.
There's your sketch. But how far is that angle from the x-axis? It is definitely 30 degrees. Your reference angle is 30 degrees. Now, if you're like, wait, how does that fit into the formula? The angle has to be in between 0 and 360. So if you're going to use the formula, you're going to have to find a coterminal angle to negative 150. How do you find coterminal angles? Add or subtract 360. Well, in this case, since it's negative, I probably want to add 360. And real quick, what's negative 150 plus 360? 210. So 210, is that in the first, second, third, or fourth quadrant? Third. Same. So third quadrant says to do the angle minus 180. What's 210 minus 180? That's how you use the formula to find the reference angle. Or you can pretty much recognize the distance it is away from the x-axis.